Hey, how's it going? Today we're going to go over a cool algorithm I found on Code Wars called the shortest knight path. So the prompt is given two different positions on a chessboard, find the least number of moves it would take to get a knight from one square to the other. Positions will be passed as two arguments in algebraic notation. For example, a knight from a3 to b5 should return 1, so a little visual that would look like this, from a3 up to b5, that's one knight move. Basic rules, the knight can't go off the board, and the board is just a regular 8x8 chessboard. So let's jump into the code. The way we're going to do this is we're going to use a breadth-first search because we want to find the shortest knight path, and a breadth-first search is great for doing that. And the way we're going to implement our breadth-first search is with a queue. That's just a standard implementation. So when we look at our, if I go back here to our prompt, the way we're given these parameters for the start and the end square are as strings, but we can't really work with those, so we're going to have to convert them into something we can use. So we have this handy-dandy little helper function called convertPoint, which takes a square and it'll convert it into, or it'll take it from chess notation and it'll convert it just to an array with a row by column. So D3 is really the third row up and the fourth column over, so just a quick visual, 1, 2, 3, 1, 2, 3, 4, and that's D3. It's a relatively simple function. So we convert both our start and our endpoints, and now that we can work with those, we make our board, and our board we're just going to use as an object. So a quick note about our object or our board. The way we're going to represent squares is as arrays of, or stringified arrays will be our keys, and our values will be the number of squares it takes to get from our start square to that square. So we'll see how that looks in a little bit, but what we're going to do is we're going to initialize our board to have the starting square as the key, and the value will be 0 because the start square is 0 squares away from itself. And a quick note on why we're using JSON stringify here. We could use the ES6 map constructor class, whatever you want to call it. I'm not a huge fan of it for this. I think it's just easier to work with an object. And the reason I am actually using JSON stringify instead of start.the toString method is because toString will actually get rid of the braces on an array on either end, but JSON stringify will not. So that's why we're using that. And so now we create our queue like we talked about on line 6, and we initialize it with our starting square in it, and we loop through our queue for the time it takes until our end square is at the beginning of our queue. And so once our end square is at the beginning of our queue, we can just be done because we know it'll be on our board. So the way we do that is first we shift off the first square of our queue, which would be our start square, and we'd store that in this location variable, and then using that location variable, we're going to get all of the moves that are available at that square. So we're going to use this helper function right here, which takes in a square, and it'll return an array of all moves, and notice this comment here, it'll return an array of all knight moves from that square, regardless of whether or not those moves are on the board and are legal moves. So you could actually move to a negative square off the board or above the board, whatever you want to think of that. Then we use check moves, which will check all of those moves that we just got in that array, and it'll just filter out the ones that are off the board, and it'll just give us back a much shorter array of all valid moves if it has a bunch of moves that aren't valid. And I split these up just because I think it's a little easier to create and just to understand making an array of all moves and then getting the valid ones. That's just preference. So now it's really nice that we have this moves array, and so what we're going to do is for every move in that array, we're going to push it onto our queue. And so just zooming out a little bit, we're going to put all of those moves onto the queue, and then we're going to check those moves. So let's say we have a start square. Before we consider, like, quote unquote moving our knight from right here, so like before we move from A1 to B3 and we check the value at that square, we're actually going to push on all of A1's moves, which would be B3 and C2, so that we can come back to those moves later after we've checked if A1 is the end square. So we come back to our code and we push on all of the available moves at the current location, or for that current move we're on, and then we will add the new square to the board position and add 1 to its move count, It's a little tricky to understand. I'm going to pause here for a second just to explain that. So what's happening is the board at the location, which is right here, this was what we shifted off. So this was the move that we started at for this iteration through, whether it's the start or wherever we are in our queue, doesn't really matter. But keep in mind that this value, if it is the start, would be 0 because start again is 0 away from 0. But if we're somewhere else, then this value would be like 3 squares away from start or 2 squares away from start or sorry, moves. So this would be like let me give you an example here just to visualize this. So from A1 to C5, we would have 1, 2. So at C5, the board would evaluate board at C5 would evaluate to 2. So what we're going to do is, if you were moving from C5 to say D7, then we'd want to add 1, which is D7 is this and C5 is this. So we're going to add 1 to the number of moves it takes to get to C5, and that's the number of moves we'll store at D7. And so we keep looping through this through our queue, and eventually the 0th element in our queue will be the n square, and then we can break out of this loop and just return the n square and its value. And if we just run some quick tests that I wrote, we just return, or all these are passing, so just a quick look at what that looks like. This is just like 10 checks, which isn't really that many, or 11 checks, I guess. But if we want to test this out on the CodeWars website, let me grab all of this and train again. I've already done this before. What a giveaway. So, haha, it's not knight, it's a horse. Great. So we put in our function here. Oh, let me just get rid of that. That was just for my own tests. But yeah, so if we run our sample tests, yay, 5 passing. And now let's run some more tests, because who doesn't love passing more tests? And we got to give it a second. Great, we're passing 1,334 specs. So I hope you enjoyed. Key takeaways, definitely just remember, anytime you implement a breadth first search, you're going to want to have a queue just to keep track of those, like not your squares, but whatever it is you're checking. Breadth first search, great for checking the shortest path. Yeah, and lots of helper functions make these functions easier to understand. Thanks for watching. Hope you enjoyed.